Hey everybody, it's Josh with CC Rainbow Monday, and we're going to go over Week 15's science experiment number 91 out of Janice Van Cleve's book, and it's called Magic Solution. Now what this is, a quick overview of the experiment. What's happening is we're using water, we're putting salt in water to create a magic solution that an egg will float in. An egg normally will not float in water because it is more dense than the water, but when the salt is in there, the salt makes the water more dense than the egg, and so the egg will float. Now, you can use really any type of salt. It would work. We were looking through our cabinet and realized we didn't even have any regular iodized salt, because like a typical homeschool family, we shop at Costco, Dollar Tree, Dollar Tree, Dollar Tree, Dollar Tree, Dollar Tree, and wherever we got this book from, Dollar Tree. And but you can use any type of salt. We're not going to use the pink Himalayan salt, just because it's so expensive. Epsom salt, we always have lots of that, so mommy can soak in the bathtub after a day of dealing with all of the crazy children. So we let her do that once every couple months. But we have lots of Epsom salt. Works totally fine. You can use Epsom salt. You can even use margarita salt, but mommy really would not like us to use that one, so we're going to leave that one behind. What we're going to do is we're going to take two glasses. We have two glasses. These are just plastic ones. This is what we'll have you guys use on campus. We'll have two different stations set up. You can choose either one. Please clean up your mess in between stations. If you want to let the kids do this themselves, we will have extra cups, and we'll have lots of salt, and we'll have a flat of eggs. Just if you're dealing with little kids, we don't want them to drop it. If you drop it in the cup, it can break, even with the water in there. So what we're going to do is take some water. The water, it works better if it's slightly warm, just because the salt will dissolve a little bit faster into it. So we're just going to take our water here. About 3/4 of the way full is fine. This is just plain old water in here. This one right here, this particular cup I have right here, I actually just did a little bit of a test. If you want to come in close, you can kind of look what we've done here. This has this. I could drop an egg right in this. You can see there's salt on the bottom of this. Now you can back the camera up. What we're creating is called a supersaturated solution, and you use this for a lot of different experiments. A lot of different experiments call for a supersaturated solution, say of borax, or if you're going to create borax crystals or sugar crystals, or even salt crystals. This science experiment ties into one that we're going to do later, where we make salt crystals, Epsom salt crystals, but it also ties into a couple of the other experiments that we've done in the past. So to kind of stretch the experiment out a little bit, if you're wanting to kind of explain more to the kids, fill your whole half an hour, you can remind them of the things that we learned in the other two science experiments, because what you're doing is when you mix the salt into the water, you're creating a supersaturated solution, which means the water is saturated with the salt. So saturated to the degree that it can't hold any more salt, and that's why we have that layer of salt on the bottom. So it's okay if you kind of go a little bit overboard and you have extra salt in the bottom. What you've done is you've created that supersaturated solution to where, if you remember from our previous experiments, water molecules have that hydrostatic bond with each other, and creating surface tension, but there's that airspace in between them, and we showed that with the rubbing alcohol, the 99% and the 91% rubbing alcohol, that we filled those spaces. So what the salt's actually doing is the salt is dissolving, it's going down into really small crystals, and it's going in and it's filling those spaces in, and it's making the water a more dense solution than just plain water. So if we take one of our eggs and we just drop it into the water, I actually may have poured myself a little bit too much here. Let me pour that out. We drop it into here. You'll see it'll just go right down to the bottom, and it's just sitting right there at the bottom. Now, with this one, I'm going to go ahead. Yeah, let's go ahead and move this out of the way so you can see this a little bit better. I'm going to pour just a little bit of water out of here. We're going to take our Epsom salt, which I have in this little container here, and we're just going to dump it in here we'll do 4, and we'll see where we're at. 4 big scoopfuls here. We'll see where we're at. We'll kind of stir it. We could have the egg in here if we wanted to. And what's actually cool, I probably could have done this, is when it's in here, see how it's kind of sitting on the bottom, so I guess it'll still work. The more that we stir it, the more that salt will get absorbed into the water, and you'll kind of slowly see the egg rise. There you go. Now the egg is floating, because we actually put a lot of salt in there, more salt than I was expecting. This other solution that I created over here, you can drop the egg right into it as well, and it will just float. Now the reason why the color is kind of a milky color, and in the science experiment book they actually call for that you take a quarter teaspoon of milk and put it into the regular water, is because they want to create that kind of that milky sort of look to the regular water solution, because they're trying to make it like a magic thing. You don't need to do that at all. It's just regular water, and it will eventually clear up. As you can see over here in the one that's been sitting for half an hour or so, it's completely cleared up. So what is happening is the egg is now able to float in the salt water, because the salt is going in and it's filling all of those different spaces. Now, something that's really kind of cool, kind of interesting, is the Salton Sea here in Southern California. You can actually go there. I've never actually done it myself. I've been there, but I've never gone and gone into the water. But it is so salty, and the water is so dense. It's a supersaturated solution, just like this is, that you can go as a human, as a person. You can go and you can just float in the water. You won't sink. Your body literally floats in the water because there is so much salt. And I believe you can do the same with the Dead Sea. That it has so much salt content in it that you can just float in it, and that's the reason why it's floating. So to wrap up, the eggs are floating in the saline solution, the salty solution, because we've created a supersaturated solution. Something that you can do with the kids is have them say, everybody say supersaturated solution, and then explain that to them and let them know what we have here, what we've created. You can also talk to them. It's kind of cool. You could take a magnifying glass when you're done, pull your egg out of the water, and then have them look at the crystals, the salt crystals that are down at the bottom of the thing. You can just kind of have them look at them, and you'll see that the crystals are smaller, and you'll kind of see that there's little bubbles. It's hard to see in this particular cup that there's little bubbles rising up to the top, and that is some of the salt kind of continuously going into the water, and the bubbles of air, like we talked about in one of the previous experiments, are kind of are coming out of the water, and they're rising up to the surface to go back into the air, because those pockets of where the air is within the water are being now filled with the salt. And that's creating our denser solution. You may want to use a spoon to let the kids kind of put it into the water by themselves, and it is pretty cool for them to be able to try that out and to set it in there. And they can you can let them bounce the egg. Say, tell them you can bounce the egg, boink, and it'll go down to the bottom, and you can kind of push it down in there. Whereas obviously this one you can't. So have fun with that one, and we will see you guys next time. As a little side note, this whole experiment has to do with density. So the density of the water is enabling the egg to float. So the egg, in this case, with the plain water, is more dense than the egg in the water solution over here. The water is more dense because the salt is denser than the egg. The salt itself is denser than the egg. And something you can do with your students is talk to them about density. What is density? The kids don't really usually know what density is, and so you can a good way to kind of explain it is if you had a say a bag or a box or something that was full of marbles, and you had another identically same size box that's full of say feathers, the fluffy little white feathers that you have like out of a feather pillow or something. And you can ask the kids, so which one do you think is going to be heavier? Oh, well, the one with the marbles in it is going to be heavier. Why is that? Well, because the marbles are heavier. You know, they're not going to know why is that, and it's because of the airspace in between them. The feathers have a lot of airspace in between them, whereas a marble is very dense. The molecules are actually compacted much tighter together, and so what you could show them is you could have them get into their molecules, their water molecules, and have them maybe spread themselves really far apart, and then come together and squeeze together. You could even have all the kids hold hands in a circle and have them be spread, as far apart as they possibly can, and say, you guys are the same amount of kids, but you're taking up this much space, and then if you go and you squeeze them all together and make them squeeze as tight in together in a bunch as possible, they're more dense. They're compacted tighter together, and that's what density is. When something is more dense or less dense, it's just the amount of molecules that are compressed within a specific amount of space. So the Epsom salt, or the salt in general, that's put inside of the water, it's filling the spaces in between the water, making the water with the combination of the salt more dense than the egg actually is, including the egg shell, and the egg shell is fairly dense, but everything within the egg is not as dense. We also could talk about buoyancy. Buoyancy is something floating. Fish are buoyant because they have their little air bladder inside of their bodies that they can fill up or shrink down with air, which makes them more buoyant, because if they're pumping more air into their bodies, they're going to be less dense. So the fish may naturally sink, just like when you're in a swimming pool. You can maybe give the example of if you're in a swimming pool and you're floating around, you're swimming or something, and then you want to go down to the bottom of the swimming pool. You go down to the bottom of the swimming pool with your lungs full of air. It's really hard to stay down at the bottom. You kind of have to keep swimming to force yourself to stay down at the bottom. But if you let all your air out, you'll just sink right down to the bottom, and you'll stay there until you jump up and try and swim to the surface. That's because you actually have that small amount of air that's inside of your lungs is making you buoyant, where it's actually making you less dense than the water. But then when you let that air out of your lungs, you're becoming denser than the water, and you're becoming less buoyant, and so you'll sink to the bottom of the pool. Something else too is if you have a piece of meat and a piece of fat, and you were to put them in like an aquarium of water, the meat is denser than the water, so the meat will sink to the bottom, but the piece of fat carved off of a piece of beef or something like that, an actual just hunk of fat, will float up on the surface of the water. And you can actually, if you have a really chunky person, they're going to more easily float in the water because fat is less dense than water, than someone who's just solid muscle. They'll have a lot harder time. They'll have to swim more.
Mrs. Miller floats.
And they'll have to swim more because someone that's just solid muscle will sink more easily to the bottom because muscle is denser than water. And so, anyhow, you can talk about all those different things, fill up your half an hour. Please clean up your mess when you're done. Make it nice and neat for the next tutor. You don't necessarily have to dump your water out. Maybe I think we'll have a second pitcher there that you can dump your supersaturated solution into, and we'll just go from there.